Bakit daw po si Aaron?
Sino, sino?
Si Aaron po.
Ay, anong meron?
Ikikik daw po.
Ikikik. Ay, ikaw na lang kayang ikik ko.
Joke lang, sir.
Wala namang nagsasalita. Dito ba yung ano? O sa kabila? Yung nagpakilalang maingay na babae? Sa kabila siguro yun. Sino? Wala nang ibang chika bukod sa 5K. Tingnan niyo po si Minta Mayor. Bakit pa utos ka? Ba't hindi na lang ikaw ang tumingin? Inuutusan mo pa ako. Hala, mag-discuss na nga lang ako. Puro naman kayo nakamute. Okay. So last time, we discussed frequency shifting and the different parameters that we need to consider when we're dealing with FSK. So that it includes bit rate, baud rate, and the bandwidth. Okay, so we already discussed different formulas to solve the parameters involving FSK. Okay, ay balikan pala natin yung ano. Are. So a rectangular polar baseband signal is used to modulate an RF carrier in FSK. If the baseband signal has a data rate of 200 kilobit per second and the two RFCs are 150 kilohertz apart, determine the bandwidth. Okay? So we have, so kapag ganito, kapag when we're dealing with rectangular pulse, so meron tayong additional formula na kailangan gamitin. So that is bandwidth. Ano ba yung formula? T Uy, nasulat ba to? Okay, T is equal to 1 over data rate. Okay? So 1 over the data rate, 200,000. So that is 5 microsecond. Okay? So 1 over 200,000. So that is 5 microsecond or 5 times 10 to the negative 6 second. Okay? Then bandwidth is equal to 1 over 2t. So 1 over 2t, 1 over 5, 1 over 2 times 5 times 10 raised to negative 6 is equal to, ano sagot? 1 over 2, 5 raised to negative 6.
100,000 po.
Okay, so that is 100 kilohertz. Okay? So, ang formula natin, so that is bandwidth is equal to 2 delta F plus 2P. Okay? So, ang 2 delta F natin is given by 150 kilohertz plus 2 times 100 kilohertz. So, ang sagot po ay 350 kilohertz. Okay? So kapag yan ay rectangular pulse baseband signal. Okay? So yan lang, binalikan ko lang. Okay. So moving on. Moving on. Here. Okay. So, napasa ko na naman din itong PowerPoint presentation sa inyo, no? So again, also we already discussed on how to find the bandwidth, okay? Yet, there's another method on how to find the bandwidth of frequency shift keying, okay? That is to use the Bessel function or the Bessel table. Okay? So Bessel function can also be used to determine the approximate bandwidth of an FSK wave. Okay? So basically, it is to be able to use the Bessel function, you need to compute the H factor or the modulation index. So modulation index siya sa frequency modulation. Okay? So dahil tayo ay digital, ang tawag sa kanya ay H factor. Okay? So H factor is equal to the absolute value of Fm minus Fs over 2 all over the input bit rate over 2. Okay? So makita nyo, makakancel lang yung 2. So H factor is equal to the absolute value of the difference of the mark frequency and the space frequency over the input bit rate. Okay? So halimbawa, using a Bessel table, determine the minimum bandwidth for the same FSK signal with a mark frequency of 49 kHz, a space frequency of 51 kHz, and an input bit rate of kilobits per second. Okay? So to be able to solve this one, we need to write the given. Okay? So the given are given. So ang given ay Fm, which is equal to 49 kilohertz. Fs is equal to 51 kilohertz. Okay? And Fb is equal to 2 kilobit per second. Okay? So again, we need to calculate H. So H is equal to the absolute value of Fs minus Fm over 2. Okay? So this is equal to 49 minus 51 over 2. So this is 2 over 2, which is equal to 1. Okay, remember, when using this formula, the unit should be of the same value. For example, this one is gigahertz. Yung isa ay na kilohertz. Dapat i-convert mo muna yung either of which sa gigahertz or sa kilohertz. Dapat equal sila. Okay? Next. So we all know that the H factor or the modulation index is equal to 1. Okay? So paano natin gagamitin sa modulation index? Using the Bessel function table. Okay? So as you can see, these are represented, or the Bessel function table is represented by modulation index or the H factor, the carrier, and the sideband signals. Okay? Okay? So, kailangan nyo i-memorize yung modulation index from 0 to 10. Okay? Then, ito naman, increasing lang. Okay? So, pag sinabing 1 yung ating H factor, so meron tayong 3 sidebands. Okay? So, that is J1 to J3. Kapag 1.5, meron tayong 4. Kapag 2, meron tayo ulit 4. So, ganun lang yan. Okay? So, kailangan nyo lang siyang i-memorize. So bandwidth when using Bessel function table is equal to 2 multiplied by the number of sidebands times FA. Okay? So FA is the highest modulating frequency. So FA can be solved as FB over 2. Okay? So meron tayong bandwidth na 2. Okay, number of sidebands kasi daw ang H natin ay 1. So bibilang tayo 1, 2, 3. Hindi mo isasama yung J0. J sub 0, that is your carrier signal. Okay? So 3 times anong FA? So FB ang given po natin ay 2 over 2. So basically, this is cancelled. So bandwidth is equal to 2 times 3, which is equal to 6 kilohertz. Okay? Nagets po ba?
Hindi po.
Ha? Hotdog. Hindi mo nagets? Nagets ba?
Ox lang po.
Sino hindi nakagets? Sorry.
Lang po.
Okay, so ulitin natin. Stop share. So, isulat natin ng mas maayos. Okay, so there are different methods on how to solve the bandwidth of frequency shifting. One of which is using the formula, and second is using the Bessel function table. Okay, so when using the Bessel function table, we need to compute for the H factor. So H factor is basically unitless. Okay, so H can be computed using the formula, the absolute value of the difference of the mark frequency and the Fs, or the space frequency over 2. Okay, so in the given, we have 49 kilohertz and 51 kilohertz as their FM and Fs. So divide both sides by 2. So that is 49 minus 51, so that is 2 over 2, which is 1. Okay, again, H factor is unitless. Okay, so how are you going to use this H factor to be to solve for the bandwidth? Okay, so H factor or the modulation index can be used in analyzing. Here are my drawings. Nako, ayaw mag-clear. Erase ko na lang. Tayo din mag-erase. Select. Ganon. Ayaw mag-erase. Anyway, so this is a Bessel function table. Okay, as you can see, different modulation and index has different sidebands. Okay, so this one is your carrier signal. Okay, so that is not considered your sideband. Okay, so J1 to J14. So these are considered the sidebands. Okay, so we have computed that the H factor in the given problem solving has a modulation index of 1 or H factor of 1. Okay, so kailangan nating malaman kung ilan yung number of sidebands kapag ang modulation ay 1. Okay, so hindi natin i-count si 0.77 kasi siya ay carrier signal. Ang kailangan natin ay sidebands. So ang sidebands po niya ay 0.44, 0.11 at 0.02. Okay? So meron po siyang tatlong number of sidebands. Okay? So sabi ko sa inyo, kailangan nyo i-memorize yung modulation index. So pag ang na-compute nyo pong modulation index ay 4, ang number of sidebands po ay 1, 2, 3, 4, 5, 6, 7. Okay? 7. Okay? Kapag 10, edi 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? 14 na kanyang number of sidebands. Stop share. Share ko to. Okay. So we by computing the H factor, we already know that a modulation index of 1 has 3 corresponding sidebands. Okay? And the formula in finding the bandwidth using Bessel function table is bandwidth is equal to 2 times the number of sidebands times FA. Okay? So ano yun? Stop share. And FA is equal to FB over 2. Okay? So, B is equal to 2. The number of side bands based on the Bessel function table is 3 times FB. Ang giving FB sa given ay 2 kilobits per second over 2. So, this is cancelled. So, bandwidth is equal to 6 kilohertz. Okay na? Nagets na?
Yes po, sir.
Okay.
Yes po.
Okay. Any question? Question, mga Beshiwap. Wala na? Sige, anong tanong? Hoy, anong tanong? La? Gets na? Okay, dahil gets na, dahil dyan, tayo ay mag-sit work na. So, kumuha na kayo ng short band paper.
Sir, paano po pag wala pong short band paper? Yellow pad lang po available.
Ako, ay bahala ako.
Sige po. Manghihingi na lang ako.
Bahala ka. GF.